that we have discussed yesterday. I will continue it. So yesterday I have thought about why bonds forms, why atom tends to form bond, what are the different types of bond, how electronegativity decides the nature of bonding, and various classification of bonds. Now we will today discuss something regarding ionic bond. The very first type of bond is ionic bond or electrovalent. Ionic bond or electrovalent bond. We will discuss regarding ionic bond or electrovalent bond. So, ionic bond or electrovalent bond is formed by electropositive and electronegative atom. When electropositive and electronegative atom interacts, they result in formation of ionic bond, or we called as electrovalent bond, and such compounds are referred as ionic compound or electrovalent compound. Such compounds are referred as ionic compound or electrovalent compound. Okay. Now, electropositive atom tends to show loss of electron. Electronegative atom tends to show gain of electron. See, this bond is formed by gain and loss of electron or by complete transfer of electron. Electron is transferred from electropositive to electronegative. Okay, and this transfer of electron results in creation of charges. The electropositive unit which transfers electron generates a positive charge chemical unit called as cation, and electronegative unit which gains electron generates a negatively charged unit called as anion. And ionic bond is nothing but it is the electrostatic force of attraction between cation and anion. Okay, so ionic bond or electrovalent bond is formed by gain and loss of electron. Okay, now let's see it how it happens. A is an electropositive atom. It forms a cation like Ay plus plus Y electrons. Okay, now another atom like B gains X electrons and forms an anion Bx minus. This positively charged unit is called as cation and this negatively charged unit is called as anion. So we can write this equation as, now multiplying this by X and multiplying this by Y, so that we have number of electron lost equal to number of electron gained. So we can write XA plus YB generates XAY plus YBX minus. This is cations and this is what below? Anion. Okay, and some energy is released. Okay, so now positive charge on the cation is Y plus. Y plus is referred as, Y plus is called as cationic electrovalency of atom A, whereas X minus is referred as anionic electrovalency of atom B. So now these atoms A, Y plus and Bx minus, there is electrostatic force of attraction in these ions, and this electrostatic force of attraction is called as ionic bond or electrovalent bond. Just say it, or we can write it as, and we can write the ionic compound as AX By. This is the way this ionic compound is written. Okay? Then, so this is the way ionic compounds are formed. Now, conditions for formation of ionic compound or electrovalent compound. Condition for formation of ionic compound or electrovalent compound. Okay, so just see it. First condition is the atom which is relatively electropositive must have low ionization energy or ionization potential. Low ionization energy or ionization potential. The atom which is relatively electropositive must have low ionization energy and ionization potential. This condition helps in formation of cation. Low ionization potential demand will easily generate cation. Okay. Second, the atom which is relatively electronegative must have high electron affinity. High electron affinity. It means the atom which is relatively electronegative should easily form anion, and large amount of energy is released in formation of anion. So this will help in stabilizing the anion. Okay. And third condition, the formed ionic compound must have high lattice energy of dissociation. High lattice energy of dissociation. So these are the three conditions which are required for formation of ionic compound. Now I will just explain what is lattice energy of dissociation. So write lattice energy of dissociation. So this is lattice energy of dissociation. Lattice energy of dissociation. So lattice energy of dissociation is defined as the amount of energy released when 1 mole of solid ionic compound is converted into its constituent gaseous ions. Just say it. It is the amount of energy required required to break 1 mole of ionic compound into its constituent gaseous ions, just say it, and its reverse is referred as lattice energy of formation. So just say it, for example, if we have salt like AXBY, Q is the amount of energy given it is existing in solid state, the compound is ionic. So it will give XAY plus YBX minus. In which phase? Gas phase. So this Q is referred as lattice energy of dissociation. The Q is referred as lattice energy of dissociation. AXBY is giving XAY plus gas plus YBX minus gas. Okay, and this is your ionic compound. Q is the amount. Reverse is called as lattice energy of formation. Okay. Now, for example, if we have NaCl solid, what is lattice energy of dissociation? Q converting into Na plus gas plus Cl minus gas. We have something like this. If we have Al2S3 solid, heat given so as to convert into 2Al3 plus 3S2 minus. In which phase? Gas phase. This amount is called lattice energy of dissociation. Let's say K2SO4 plus Q energy, it is converted into 2K plus gas plus SO4 2 minus gas. So I think you have gone through the word, or it is sometimes written as delta H. Change in enthalpy is one of the symbol for heat. Delta H, lattice energy dissociation. Q is also referred as delta H, lattice energy dissociation. Now I will just try to explain. Next heading we have thermodynamics. Thermodynamics of formation of ionic compound. Thermodynamics of formation of ionic compound. Now we will try to explain it. Let's say there is an atom A. A is going into A Y plus Y electron. A in gas phase and giving Y electron. So we can say what is energy is required in this process? Delta H, ionization energy. This energy is called as ionization energy. Okay. Now there is an atom B in gas phase gaining X electrons and forming Bx minus in gas phase. So this process is endothermic plus Q. This process is exothermic Q dash, but we call as delta H electron affinity. Now again just see it. If we multiply this equation by X and multiply by Y, now 1 mole atom requires how much energy? This much. So X mole will require, we have to multiply by X. So Y mole will require energy Y, and again we have this. Okay, now just see it. ay plus xay plus gas plus ybx minus gas, these combine to give compound axby, solid ionic compound. Obviously heat will be released, Q double dash, and we call this heat as delta H, lattice energy of formation. Now if you add all these reactions, what we are going to get? XA gas, XA gas plus YB gas, and these ions will cancel out. Finally we giving AXBY solid. This is ionic compound. So what we can write? Delta H of this. So delta H of this reaction, delta H ionic compound formation, ionic compound formation. So what we can write? Heats are additive, so we can write it as delta H ionic compound formation is equal to what we have? X times delta H ionization energy plus Y times delta H electron affinity plus delta H lattice energy formation. So we can write this. Now we know that this term will be positive, this term will be positive, this term will be negative, and this term will be negative, and overall sum will be negative, because we know that bond formation is an exothermic process. We can write plus Q triple dash. Bond formation is exothermic process. Greater the amount of energy release, more stronger will be the bond. So how energy release can be increased? Because for energy release, the sign of delta H should be negative. So how energy can be released? By low value of positive low values, high negative value of electron affinity, and again high value of lattice energy of dissociation will result in very high value of negative lattice energy of formation. So overall sum will be first, and this explains why we have conditions. So this is thermodynamic explanation of the condition why for the formation of ionic or electrovalent compound, lattice energy of dissociation should be high. So reversibly lattice energy of formation should be highly negative, and simultaneously the ionization energy of electropositive atom should be low and electron affinity should be very high. So all these terms, these negative and negative will reinforce, and finally overall term will be what? Negative. And greater the negative sign, we can have more stronger will be the bond, because bond formation is an exothermic process. Okay. Now this explains. This is the thermodynamics of formation of ionic compound. Next we have convention for writing ionic compound. Convention for writing ionic compound. Convention for writing ionic compound. How to write ionic compound? Okay. Now just say it. First convention. First cation is written and then anion. First condition is that first cation is written and then anion. Second condition is first cation and then anion. Second condition is the number of cation and anion required for maintaining charge balance are written in subscript. Why this is also referred as charge balance condition. Charge balance condition. Now, as we know that ionic compounds are electrically neutral, it means total positive charge must be equal to total negative charge. Okay, so ionic compounds are electrically neutral. So for maintaining charge balance or electroneutrality, we have to adjust the number of cation and anions. Third, cationic and anionic electrovalency of ions is not indicated. So these are the three conventions by which first we have to write cation and then we have to anion. Second, we have to maintain charge balance because total positive charge to total negative charge, and charge balance is to be written in dot one, and charge balance is maintained. Charge balance is maintained by simplest ratio of ions. Okay. Fourth is formula of ions should not be altered only their number can be adjusted for maintaining charge balance. So these are the conditions or conventions by which ionic compounds are written. First cation is written and then anion. Number of cation and anion required for maintaining charge balance are written in subscript. Why we are maintaining charge balance? Because it's the electrical charge balance is maintained by simplest ratio of ions. Okay, and third is cationic and anionic electrovalency of ion is not indicated. Fourth is formula of the ion should not be altered, only the number can be changed for maintaining charge balance. Now we will try to use this convention for writing. Just see it. Okay. Now let's say if we have a cation like Ay plus anion like what will Bx minus. Now just take LCM of y and x. So it is what will xy. So it is the simplest ratio. How we can retain simplest ratio? we should have what? We should have x ay plus and y bx minus. So what is total positive charge? Xy plus. What is total negative charge? Minus xy. This is the way we have to take LCM of the cationic and anionic electrovalency. And so what we can write this, how we will write this formula? Now we have x, we have to write like ax by. Numbers are to be written in subscript. It should not be like this, ax by. And finally, one of the more important thing, that cationic and anionic electrovalency ay plus x b x, it is basically this compound, and there is an ionic or electrovalent bond. There is an ionic or electrovalent bond between ay plus and bx minus, but it is our convention that cationic and anionic electrovalencies are omitted, and during this charge balance condition we don't have to play with the formula of the ions. We are only allowed to adjust numbers, and that to be in simplest integral ratio. Okay, just say it. So we can write this compound as ax by. Okay, for example, just say it, if we have a compound containing Al3 plus and sulfide ion, so what will write this as? Al2S3. We don't have to write Al2S3. This is wrong. Finally, we don't have to write like Al3 plus whole twice S2 minus whole thrice. This is also wrong. So it is convention that cationic and anionic electrovalencies are omitted. Okay, so we have to write the formula like Al2S3, not by this, not by this, or we can indicate simply these. This working can be simply indicated by ay plus bx minus. We have to cross these valencies without changing the formula of ions. So what we can write formula is ax by. Okay, now we can directly write it as, crossing this valency we can write Al2S3. What is cationic electrovalency of aluminium? Plus 3. What is anionic electrovalency of sulfur? It is minus 2. So this is the convention. Now for example, one nice example, Hg22 plus Cl minus. This ion is referred as mercurous ion. This is chloride ion. So how we should write this formula of the compound? We don't have to play with the formula of the ions. We are only allowed to adjust their numbers, and that to be in simplest integral ratio. So we can have, how we can adjust this? Here and here. So what is formula? Hg2, this is whole one cation, and Cl2. We cannot cancel it. It is not empirical formula. It is simplest. It is the simplest formula, which is in the simplest ratio of ions maintaining charge balance. We are not allowed to play with the formula of the ion. We are only allowed to there adjust numbers. So we cannot cancel out 2 and 2. Okay, let's say we have ion like potassium ion, we have ion like S2O2 minus. S2O2 minus ion is called as thiosulfide ion. This is potassium ion. Potassium ion. So what we should write this compound as? Without, we are not allowed to play with the formula. So what we have to only allowed with to play with, we can only allowed with charge balance. So how we can maintain charge balance? Like this. So it is K2S2O2. So I think the convention has been clear. Then this is the way by which ionic compounds are written. First cation and then anion. Second, that their numbers required for maintaining charge balance are written in subscript, and their cationic and anionic electrovalencies are omitted. Okay. So we have this. Next we will write the characteristics. Characteristics of ionic compound. Characteristics of ionic compound. We have to write what is the characteristics of ionic compound. First First characteristic, ionic compound are non-directional. Ionic compounds are non-directional. They consist of array of alternatively placed cation and anion. They consist of array of alternatively placed cation and anion. So, or we can say that ionic compounds are omnidirectional. Now just I will try to explain this statement. Just say it. So ionic compound consists of cation, anion, cation, anion, cation and anion infinitely. Closest neighbor of cation is anion and closest neighbor of anion is cation. A cation cannot have another cation as its closest neighbor because it will increase the repulsive force, and we know that in ionic compound attractive force is more than repulsive force because cation has closest neighbor anion. Okay, and we know that the Coulomb formula is inversely proportional to R square. So if we take cation as a reference, then its anion will be closest. So, and the force between cation and anion is attractive, and force between cation and cation is repulsive, and force between anion and anion is also repulsive. So F attractive is more than F repulsive. So we go in any direction, we just take it. So it consists of array of cation and anion, alternatively placed cation and anion. So direction is meaningless in such compounds. Bond angle is meaningless in such compounds. So you go in any direction, you will find that there is arrangement of cation and anion. So we see that compound is ionic compounds is non-directional, or we can also say that ionic bond is non-directional, or it is in omnidirectional. In every direction. If you go in this direction, you will find mirror image in opposite direction. So this is the meaning of the ionic compounds are non-directional. Okay, bond angle is meaningless in case of ionic compound. Second condition, ionic compound are hard and brittle. Ionic compounds are hard and brittle. Why ionic compounds are hard and brittle? Because of a strong electrostatic force of attraction. That strong electrostatic force of attraction makes them hard. Okay. Then brittleness, they are brittle because the repulsive force is also very high. For example, just say it: cation, anion, cation, anion, anion, cation, anion, cation, cation, anion, cation, anion. This is ionic compound. Cation has closest neighbor anion, anion has closest neighbor cation. So in this case, F attractive is more than F repulsive. So, and magnitude of attractive force is much more higher than the magnitude of repulsive force, and then strong Coulombian force of attraction makes this compound hard. Okay, but why they are brittle? When these compounds are hammered, just see it, when you hammer it, it changes the spacing. Just say it: minus plus, minus plus, minus plus, plus, minus, plus, minus, just a minute. plus minus, and we have hammered minus, minus, plus minus. Just say it. Now your hammering has locally changed the distance between these cations. So this results in F repulsive force higher than F attractive force. So ionic compound breaks. Okay. Third condition, ionic compound are crystalline in nature, and hence they are anisotropic. Ionic compounds are crystalline in nature and hence they are anisotropic. Now since crystalline solids are special types of solid which have regular arrangement of atoms or ions. So whenever some solid has some regular arrangement of atoms or ion, it is said to be crystalline. So ionic compounds are also crystalline because they have regular arrangement of cation and anion. A cation has closest neighbor anion, anion has closest neighbor cation. So this regular arrangement makes them what? Crystalline. Crystalline is only characterized by regular arrangement, and ionic compounds have regular arrangement, so they are referred as crystalline. And there is one more important property of crystalline is anisotropy. Anisotropy means various electrical mechanical properties, magnetic properties are directional dependent. Anisotropic means various electrical, mechanical and magnetic properties are direction dependent. And you will learn in the topic of solid state what is the basic meaning of anisotropy. Or we can just give one example like cation, anion, cation, anion, anion, cation, anion, cation, cation, anion, cation, anion. Now just see it. If we go in this direction, we will only encounter cations. If we go in this direction, we will encounter anions. If we go in this direction, we will encounter cation and anions. Means properties are different in different direction because different set of atoms are encountered. Okay. So this is anisotropy. Much more detail. Isotropy means everything is same in all direction. Anisotropy is opposite of isotropy. Means things are direction dependent. Okay. So crystalline solids, ionic compounds are crystalline. Crystalline compounds are characterized by regular arrangement. Ionic compounds have regular arrangement, so they are crystalline. And crystalline solid are associated with one more property called as anisotropy. Means various properties like electrical, mechanical, and magnetic are direction dependent. So this is one of the important property of ionic compound. Fourth, ionic compound are electrically conducting. Ionic compound are electrically conducting in their molten state or in aqueous solution state. So ionic compounds will conduct electricity in their molten state or in aqueous state, because in molten state it will consist of mobile cation and anions, and in case of aqueous state it further consists of cation and anions. These charged particles conduct charge and hence electricity and makes them electrically conducting. But ionic compounds are non-conducting in their solid state. Okay. So these are the various properties of ionic compound as we have discussed. and next we will discuss further more regarding these compounds.